nomenclature that we need to talk about is ionic nomenclature. And ionic nomenclature is a little bit different than molecular because we actually have to obtain the charge of each of the ions from the periodic table. So remember that in an ionic bond, I don't have two random elements or two random like an S and an F coming together. I have a metal and a nonmetal. So that metal, which is coming from the left-hand side of the periodic table, carries a charge. And when compounds ionize, both the metal and the nonmetal ionize. So metals are going to have a positive charge, and nonmetals are going to have a negative charge. Nonmetals are called anions. Metals are called cations. So once I get the charges off the periodic table, or off of the polyatomic ion sheet, then I crisscross them, making the atom electrically neutral. So how do we obtain the charges? All atoms want to have 8 valence electrons. We will learn about that when we talk about bonding, so next unit. But for the time being, we want to count how many it would take to gain or lose, how many electrons it would take to gain or lose, to get to the closest noble gas. So if we were going to go ahead and write our charges in the periodic table so that we had them for reference for the remainder of the course, we would say that group 1 is +1, group 2 is +2, group 3 +3. Carbon's group is plus or minus 4, depending upon what it's bonding with. -3, -2, -1. Now, group 8 doesn't form a charge because they don't bond. They are what we call our inert gases. So they're going to have a specialized, they have a full valence shell. They don't need any more electrons, so therefore they do not carry a charge. So when we go to name these compounds, we want to name the ions. Polyatomic ions, their names do not change. So if it's carbonate on the sheet, it stays as carbonate. Monoatomic cations, we don't change their name. So the metals, their names are going to stay the same: magnesium, sodium, lithium, beryllium. And then for transition metals, we include the charge of the ion in parentheses. So for example, anything in the D block, or this block, with the addition of tin and lead, so anything right here, you have to be given their charge. Chromium can actually ionize up to +7. Silver will always be +1. So those are some of your charges for transition metals. And anytime you are asked to use a transition metal, you will be given the charge, with the exception of silver and, I guess, zinc. Zinc is always +2. Those two I expect you to know, so you want to go ahead and write those in on your periodic table so you have them to reference. Alright, so we've already gone over the rules. For the cations, we drop the last syllable, so exactly what we did in molecular nomenclature, where chlorine becomes chloride. So let's practice a couple. Sulfur trioxide. Sulfur is a nonmetal. Trioxide is a nonmetal. So this is actually binary molecular. So we're not going to worry about it right this second. Cesium bromide. Cesium is a metal. It is in group 1. Bromine is a nonmetal. It is in group 7. So this is binary ionic. So I would crisscross those charges. Cesium's charge is +1. Bromine's charge is -1. Those literally crisscross. CSBr. Now, you've never seen a 1 in a chemical formula, and that's because we don't write them. So if you have 1s or you have 2 2s, then those are actually going to cancel out. We drop them. The next ionic compound we come to is barium sulfate. Barium is a metal. Sulfate is a polyatomic ion. So this is binary ionic. But because I have sulfate, I know that's a polyatomic ion. It's actually going to be tertiary. Tertiary meaning I have 3. 3 or more. So I'm on my pink sheet going to find sulfate. It is SO4 -2. Barium, Ba, with a +2 charge. Sulfate with a -2 charge. Those are literally going to cancel out. BaSO4. Alright, ammonium chloride. Ammonium chloride technically doesn't have a metal, but ammonium is a positively charged polyatomic ion. Chlorine is a negatively charged ion. That is a tertiary compound because it has more than 2 elements. NH4 plus is ammonium, and I'm getting that off of page 7 of my reference table. Chlorine with a negative 1 charge. When those crisscross, they're going to cancel NH4Cl. Alright, I know that 7, 8, and 9 are all molecular compounds because they have these prefixes. Notice on the ionic compounds, we have no prefixes, only on the molecular. So the last ionic on this page is beryllium oxide. Beryllium oxide is going to be binary ionic. I know that because it ends in "ide", meaning that it's an ion off the periodic table. Beryllium is in group 2, meaning it's got a +2 charge. Oxygen is in group 6, meaning it has a -2 charge. When those crisscross, we get BeO. Now we'll come back and practice the molecular examples on your sheet together in class, but for right now, that's a pretty basic introduction into how to do ionic compounds. The only extra piece is if I had a charge that needed to be distributed to everything. So let's do 13, but let's edit 13 to calcium phosphate. 8 means it's a polyatomic ion, which means it's going to be a tertiary compound. Calcium has a +2 charge. Phosphate has a -3 charge. So clearly those aren't the same. They won't cancel out. What happens is that the 3 from phosphate moves to calcium. I need the 2 from calcium to distribute to both the P and the O from phosphate. The only way to do that is to put it into parentheses. So that's a brief overview of ionic nomenclature. Remember to double check your charges off the periodic table and the polyatomic ion sheet to make sure that you're accurately crisscrossing and making sure that your subscripts are exactly what they need to be.